Hello and welcome back to our 7th lecture. We are going to be jumping into algebra now and starting a new chapter on linear equations and applications. So let's jump in. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers, a is non-zero, and x is the variable. So all that's saying is you have 2x plus 1 equals 0. The 2 would be the a, the 1 would be the b. So all it's saying is that a and b are numbers, and it has some x, which is an unknown variable. A solution to an equation is a value of the variable that makes the equation a true statement. The set of all solutions to an equation is called the solution set of the equation. Let's try 2x minus 4 equals 0. So the first thing you would do would be add 4 to both sides. Then you have 2x equals 4. So then we divide by 2. So you have x equals 2. So your solution set would be 2. However, you can't have more than one number in your solution set if you have something like x squared minus 25 equals 0. So adding 25, you get x squared equals 25. And then when you go to take a square root, we don't forget that we plus or minus. So x is plus or minus 5. This means our solution set for this problem would be 5 and negative 5. Moving on. Let's go ahead and solve this more complicated linear equation. We want to distribute anything outside of a parenthesis. So negative 3 times w is negative 3w. And then negative 3 times negative 4 is positive 12. Plus 5 equals 10. And now we want to also distribute this negative. So this is minus w. And then we distribute the negative again, so it's minus 1. Now on each independent side, we can combine like terms. So our like terms on the left side are going to be 12 and 5. And our like terms on the right side are going to be 10 minus 1. So we'll get negative 3w plus 17 equals 9 minus w, since 10 minus 1 is 9. Now we can move things back and forth around this equal sign. So what I'm going to do first is add 3w. I like to add large negative numbers because I don't like negative numbers. You can also you can also add the w. So now here we have a negative w plus 3w. So you can think of that as negative 1w plus 3w, right? Which is going to be 2 w's. Then we subtract 9 from both sides. And 17 minus 9 is 8. Lastly, we'll divide by 2. So we get w equals 4. Moving on. So next we solve a linear equation by clearing fractions. What I usually do is look at all of the denominators. So we have 15, 2, and 5. And I try to find their least common multiple. That way they all clear at the same time. So the least common multiple of 15, 2, and 5 is going to be 30, because 30 divided by 15 is 2, 30 divided by 2 is 15, and 30 divided by 5 is 6, right? Oops, 3, 30. So they all multiply to 30. So that means I'm going to multiply every single term in my equation by 30. So I'll have 30 times m minus 2 over 5 minus 30 times m minus 4 over 2 equals 30 times m plus 5 over 15 plus 30 times 2. Very important, don't ever forget this whole number. It still needs to be multiplied by 30, even though it doesn't have a fraction, because we're multiplying every other term by 30. So you either do the multiplication to all of the terms or none of the terms. So we're doing them to all of the terms. Okay, so now we know that 30 divided by 5 is 6. So I'll have 6 left over here times m minus 2. We know that 30 divided by 2 is 15. So I'll have 15 left over here. 30 divided by 15 is 2. So 2 times m plus 5 plus, and then 30 times 2 is 60. Now this is a much nicer equation that we know how to solve. It's similar to the previous example. So the first thing I'm going to do is distribute the 6. So 6m minus 12. And then this is a negative 15 times m is negative 15m. Negative 15 times negative 4 is positive 60 equals 2 times m is 2m, 2 times 5 is 10, plus 60. Next, we'll combine the like terms. So I have 6m minus 15m is negative 9m, and then negative 12 plus 60 is positive 48 equals, and then on this side I just need to add the 10 and the 60. So this is 2m plus 70. All right, next I'm going to add the 9m to both sides. So I get 48 is equal to 11m plus 70. All right, I'm going to finish the problem over here. So we're at 48 equals 11m plus 70 because I'm running out of room. So minus 70 on each side. Let's do this to make that clear. 48 minus 70 is negative 22 equals 11m. Next we'll divide by 11. So we get negative 2 equals m. Moving on. Next we'll talk about conditional, contradiction, and identities. These are all different types of equations. So a conditional equation is true for some values of the variable and false for other values. So these are what we've been practicing so far. So it's like if you had x plus 1 equals 0, and that means x equals negative 1. So true for negative 1, however, it would be false for 2, right? Because if you plug in 2 for x, you get 2 plus 1 equals 3, so that would be false. An equation that is true for all values of the variable for which the expressions in an equation are defined is called an identity. For an example, you could have 2x equals 2x. So this is true for any number. And lastly, an equation that is false for all values of the variable is called a contradiction. And that would be is if you had something that said like x equals x plus 2. That's false for all numbers. Or if you end up with 0 equals 2. Right? That's false, a false statement. And then some additional examples would be if you had something like 3 times 2x minus 1 equals 2 times 3x minus 2 plus 1. So distributing this 3 will get 6x 3 equals 6x minus 4 plus 1. So 6x minus 3 equals 6x, and then negative 4 plus 1 is negative 3. If you wanted to add the 3's to both sides, you can see that we'll get 6x equals 6x, which is always true. So this would be an identity. The solution set for identities are all real numbers, which is the big double R. Okay, next, let's do one more example. Let's do something kind of similar. So let's say we had 3 times 2x minus 1 equals 2 times 3x minus 2, right? So again, we'll start by multiplying this 3 in. So we'll get 6x minus 3 equals 6x minus 4. And then I can subtract 6x from both sides. And I get negative 3 equals negative 4, which is false. So the solution set would be the empty set, or you could say no real numbers, you could say false. So that's the difference between conditional identity and contradiction equations. Let's move on. A rational equation is an equation in which each term contains a rational expression. So these are the two examples: a rational expression being these fractions. So let's talk about how to solve these. For number 1, I'll do that one up here. We have 12 over x equals 6 over 2x plus 3. Now, each of my fractions has an x in it, so if I wanted to clear the fractions, I could multiply by x. However, I also need to think about this little 2 right here. So I'm actually going to multiply all of my terms by 2x. So I'll have 2x times 12 over x equals 2x times 6 over 2x plus 2x times 3. Remembering not to forget that whole number, because if we're multiplying, we need to multiply every single term, right? Okay, so now the x's here and here will cancel. The whole 2x will cancel in this fraction though. So what we're going to have left over is going to be 2 times 12, which is 24, equals 6, because everything else canceled out, plus 2x times 3, which is 6x. From here, we can just subtract the 6 from both sides. 24 minus 6 is 18. Divide by 6 on each side, and you get 18 divided by 6 is 3. All right, let's do number 2. So we have x over x minus 4 is equal to 4 over x minus 4 minus 4 over 5. Now, if we want to clear all of the fractions, I know I need to multiply everything by an x minus 4 to get rid of those. But I also need to multiply everything by a 5 to get rid of this fraction. So I'm actually multiplying everything by 5 times x minus 4. So you see, again, every single one of my terms gets both a 5 and an x minus 4. From here, these x minus 4s will cancel, these x minus 4s will cancel, and then these 5s will cancel. So left over, I'll have 5x equals 5 times 4 minus x minus 4 times 4. So distributing, multiplying, all that stuff, you get 20 minus, and then you need to distribute the 4. So that's 4x plus 16. And I kind of skipped a step there. The reason it's plus is because this negative right here. So we would have had minus a minus 4. I'm going to squeeze this problem in right over here. So we're at 5x equals 20 minus 4x plus 16. So we can add the 4x to each side to get 9x, this was plus 4x, equals, and then 20 plus 16 is 36, and then divide by 9. So you get x equals 4. Okay, moving on. All right, I like to do complicated problems just so y'all can see how that they would be done. So let's go ahead and run through this one. Now the key here is remembering how to do our favorite thing in the world in algebra, which is factoring. So we are going to need to factor this quadratic. By quadratic, you mean anything that has a squared term in it. So first, let's just factor. We're going to need to factor this boy. So y squared plus 8y plus 15. So hopefully you remember what's called the AC method, which is where we take the number in front of the squared term, which in this case is a 1, and then we take the number without a letter, or the constant term, and we multiply them together. So 15 times 1 equals 15, right? From that, we then try to figure out two numbers that multiply to 15, but add to positive 8. Okay, one more time. We need two numbers that multiply to 15, but add to positive 8. Those two numbers are going to be 5 times 3. So this means that y squared plus 8y plus 15 is equal to y plus 5 times y plus 3. I'm going to now briefly explain why this is true. If you would like to skip forward in the video because you remember how to factor, go ahead. If not, stay with me for a second. So we have y plus 5 times y plus 3, yeah? So multiplying across, I'll have y times y is equal to y squared. Y times 3 is equal to 3y. Y times 5 is equal to 5y. And 5 times 3 is equal to 15. This gives us y squared plus 8y plus 15, which is what we wanted. That was our goal, to get back to this. So essentially what you're doing when you're doing the AC method up here is you're finding these two numbers. So you can see that this last step when we distribute out multiplying two binomials is multiplying these two numbers together, right? So that's why they have to multiply to 15. But these intermediate steps where we do the 5 multiplied by the y and the y multiplied by the 3, those are adding to our middle term. So this is actually why we use the AC method, because the last two terms multiplied need to equal the last terms, and the middle two terms added together need to equal this boy. So we always want to find two terms that multiply to 15 but add to 8. I hope that that makes sense. I'm going to erase this and move on with the problem now. Okay, so now what we can do is we can replace y squared plus 8y plus 15 with y plus 5 times y plus 3. We do want to do this, I promise. This is actually fantastic news because in my denominators, I have a y plus 3 and I also have a y plus 5. So if I multiply every single term by y plus 3 times y plus 5, I can clear all of my fractions. which is fantastic because that is the goal, is to clear all of the fractions. So I'm going to have y plus 5 times y plus 3 multiplied by 6 over y plus 5 times y plus 3 minus y plus 5 times y plus 3 times 2 over y plus 3 equals y plus 5 times y plus 3 times negative 4 over y plus 5. Okay, so now we'll clear the y plus 3's and the y plus 5's out of my first one. The second one I can get rid of the y plus 3, and the last one I can get rid of the y plus 5. So that leaves me with 6 minus 2 times y plus 5 equals negative 4 times y plus 3. All right. Distributing this negative 2, I can get 6 minus 2y minus 10 equals, and then distributing negative 4y minus 12. Then I can combine these like terms. So 6 minus 10 is negative 4, and that's equal to negative 4y minus 12. Then let's add this 4y, and then let's also add this 4 to get everything on the proper side. So negative 2 plus 4 is 2 equals negative 12 plus 4, which is negative 8. And then you divide by 2 on each side, and you get y equals negative 4. Good job, everybody. That was one complicated problem. And I'm going to move on. All right, now we're going to get into applications. So the first application we're going to talk about is simple interest. We usually denote interest as I. So the simple interest I for a loan or an investment is based on the principal amount of money, which is denoted P. The principal, I like to think of it as like original. So like if you borrowed a loan for $5,000, your principal would be $5,000. If you invested $2,000 in a stock, your principal would be $2,000. It's like your original one. The annual interest rate is denoted R, and the loan time is T for time, and it's generally in years. And then our formula is I equals PRT. Example, if $5,000 is invested at 4% simple interest for 18 months, then the amount of simple interest earned is, so what we'll do is we'll first identify all of our numbers and assign them to the letters. What I mean by that is $5,000 is invested, yeah? So that, ooh, yikes. So that means P equals $5,000. 4% simple interest means that my R is 0.04, because remember, with percents, we always have to move the decimal, right? 18 months is my time. Now, what's wonky is 18 months is in months and not in years, and we want years. So we know that 12 months is 1 year. So that means 18 months is 1.5 years, right? So 1 year and 6 months. So my time is actually 1.5. And I'm looking for interest, right? So I'll have I equals 5,000 times 0.04 times 1.5. So putting that into a calculator. You get 300. And that's it. Let's move on. So our buddy Kent decided to invest a total of $8,000. He invested part of the money for 2 years in a stock fund that earned the equivalent of 6.5% simple interest. He put the remaining money in an 18-month certificate of deposit, which is called a CD. that earned 2.5% simple interest. If the total interest from both investments was $855, determine the amount invested in each. Ooh, that should say account. I'm sorry, I have a typo. This should say account. Okay. So you can either choose to assign your variable to the amount invested into the stock or the amount invested into this CD. But I'm going to choose the stock. So I'm also going to make a table because I just think tables are nice. So let's do principal, interest, right? And then we'll do stock and CD and total. All right, here's my table. So I'm assuming I don't know how much is in my stock. So we're gonna let X equal the stock's principal amount, right? Now, if we read, it says he invested part of the money in a stock and the remaining money in an 18-month CD. So that means whatever he put in the stock, we'll subtract that to figure out what he put in the certificate of deposit. So that's 8,000 minus X, because out of 8,000, he put X in the stock and the rest in the CD. Okay, and then the total is he totally invested $8,000. For the interest, it said that the stock earned the 6.5% simple interest, and he had that in there for 2 years. So that means our simple interest is going to be X times 2 times 0.065, because the percent, right? For the CD, it's 18 months and it's 2.5%. And remember, 18 months is 1.5 years, right? So we'll have 8,000 minus X times 1.5 times, so we have 8,000 minus X times 1.5 times 0.025 for our interest. And then it says the total interest earned from both investments was 855, so it's 855. And I didn't specify this, but I'm using for this row, I'm using I equals PRT to find those numbers. That was my bad. Okay, so let's go ahead and move forward. So we know that the interest from the stock, so interest stock plus interest from the CD is going to equal the total interest, right? Well, that means that I'll have X times 2 times 0.065 plus 8,000 minus X times 1.5 times 0.025 equals 855. And then you'll start multiplying these things out. So 2 times 0.065 is 0.13x plus 0.0375 times 8,000 minus x equals 855. Next, we'll distribute this ugly decimal. So we get 0.13x plus 300 minus 0.0375x equals 855. Next, we'll combine the like terms, which are the x's. So you get 0.0925x plus 300 equals 855. The theme today is me running out of room to finish these problems. So I'm going to do this up here. So we were at 0.0925x plus 300 equals 855. Okay. So then we'll subtract the 300 from both sides. So you get 0.0925x is equal to 555. And then you divide on both sides. Zero 0.0925, and you should get x equals 6,000. So what this means is he invested $6,000 in the stock, which then means he invested $2,000 in the CD, because the CD was the remainder from that $8,000, right? Alrighty. Moving on. All right, this is every algebra student's favorite problem. It is the mixture problem. I know we're all very excited and we all love it. Household bleach contains 6% sodium hypochlorite. How much household bleach should be combined with 70 liters of a weaker 1% hydrochlorite solution to form a solution that is 2.5% hypochlorite? All right, what we're gonna do is also your new favorite thing. It is make a table. So we'll have the amount of solution in liters. We'll have the pure, I'm just going to abbreviate sodium hypochlorite in liters. And then we have the 6% solution, the 1% solution, and the 2.5% solution. SOLN for solution. All right. So we don't know how much is the 6% solution. So we're going to let that be our X. Then we know that there's 70 liters of the weaker 1%. So this is going to be 70 liters, right? Because the top row is amount of solution. Now what we're going to do is add going across, because if I'm going to add X to 70, I'm going to have X plus 70, because this is liters, right? I'm adding X liters into 70 liters. So it's X plus 70 liters. Next, we're going to multiply kind of going down. So I have 6% and I have X. So it's going to be 0.06X. Then I have 1% and I have 70. So this is going to be 0.01 times 70. And then I'm going to have 2.5%, so this is going to be 0.025 times X plus 70. All right, and 0.01 times 70 is just going to be 0.7. So I'm just going to do that right now, 0.7. Okay, so let's go ahead and move on to solving the problem. So we're just going to essentially make this bottom row our algebra problem here. So we have plus equals, okay? Adding across. So I'll have 0.06x plus 0.7 equals 0.025 times x plus 70. Next, I will distribute this 0.025. So I'll have 0.06x plus 0.7 equals 0.025x plus 1.75. Next, I'm going to begin to solve the equation by moving 0.7 to the other side. I'm also going to move 0.025x. So you should get 0.035x is equal to 1.05. And then you divide. So you get x equals 30. So that's 30 liters of household bleach to make this solution. All right, moving on. The last type of applied problem you could see that kind of flows with this table strategy we've been working on is going to be uniform motion. So we'll go ahead and go through this. Donna participated in a 41-mile biathlon that included running and bicycling. She spent 1 hour and 45 minutes on the, wow, typos today, bike, and 45 minutes running. If her average speed on the bicycle was 12 miles per hour faster than her average speed running, find her average speed running and her average speed riding the bike. All right. So what we're going to do first is make this fabulous table, and we'll have running, biking, and then we're going to have distance, rate, and time. Because remember that distance equals rate times time, which is also written as D equals RT. We know that we spent 1 hour and 45 minutes on the bike and 45 minutes running. So that means my time in hours is going to be 0.75 because 45 minutes is 3/4 of an hour. And then my biking is going to be 1.75. And then I don't know my rate when I was running, but I know that the average speed on the bicycle was 12 miles faster. So if my running time was X, my biking time was X plus 12, since 12 miles faster. Now distance equals rate times time. So my distance for running is going to be my rate, which was X, times my time, which was 0.75. And my distance for biking is going to be my rate X plus 12 times my time, which was 1.75. Now my total distance, I'm going to add my distance running to my distance biking, because it does say we did a total of a 41-mile biathlon. So that's my total distance. So 41 is going to equal the distance I ran plus the distance that was on the bike. So then we have 41 equals 0.75x plus, and you're distributing this 1.75 into these parentheses, you get 1.75x plus 21. Next, we will combine like terms. So you'll get, adding these two together, 41 is equal to 2.5x plus 21. And then you subtract 21 from both sides. So you get 20 equals 2.5x. And then we will divide each side by 2.5. And you get 8 equals x. So what that means is the running speed was 8 miles per hour, and that the biking speed was 20, or 8 plus 12, right? Fantastic, you guys. That concludes the lecture for today. Thank you so much for watching the whole thing, and I hope you have a fantastic rest of your day.